Welcome to Ask and Learn.
Okay, so we're doing chapter 9, problem 7. And it says a rocket of total mass 3180 kilograms is traveling in outer space with a velocity 115 meters per second. It says to alter its course by 35 degrees, its rockets can be fired briefly in a direction perpendicular to its original motion. If the rocket gases are expelled at a speed, this is for the speed of the gas, at 1750 meters per second, how much mass must be expelled? Okay, so there's a lot of information there. It's kind of confusing. So let's first think about this a little bit in a drawing. So if this is the original or initial velocity, we have a rocket and it's just traveling in this, we'll call it positive y direction here. We can say this is the initial velocity vector. Now it says that the gas is shot out perpendicularly from the rocket to alter the motion. So considering that the gases are given perpendicular in the opposite direction, so we can imagine the gas gets shot out this way, but that's going to correspond to a change in momentum or speed the opposite way, that we're going to add it at equal and opposite, because of when we shoot the gas out, the rocket feels a force from the gas back, just Newton's third law going on there. So the final velocity is going to be the addition of these two vectors. And this angle right here is what we want to be 35 degrees. Okay, so that's kind of what's going on here. And we should be able to see that, I'm going to call this top one Vx here. We should be able to see that Vx magnitude is equal to the original magnitude times the tangent of 35 degrees. Okay. So we should have here, we have the momentum perpendicular before is going to equal the momentum perpendicular after, because we know that the momentum's got to be conserved here. So we have 0 equals the mass of the gas times the speed of the gas, and we have the momentum after. This is going to be the mass of the rocket minus the mass of the gas times the final speed here. Sorry, this is the speed of the gas too. This is Vx, because we're just talking in the perpendicular component here. We don't care about the vertical component, and that's because no changes in momentum is happening in the vertical component. It's all just constant. Okay, so now we can start plugging stuff in. Well, not plugging stuff in, solving for what we want to know, right? We're trying to figure out how much gas we need to shoot out. So M gas here now becomes, if we solve this, the mass of the rocket times Vx over, then we have Vx minus V gas. Cool. So now we can plug stuff in. So we have the mass of the rocket is 3180 kilograms. And now we have Vx. Well, we can replace what Vx is by this, because we know that relation. So that's 115 meters per second times the tangent of 35 degrees. That's our top here. And we can do the same thing down here. We have 115 meters per second times tangent 35 degrees. Now we can subtract off the speed of the gas. The tricky thing is here, though, that this gas is moving in the left direction and Vx is in the right direction, so we have to make sure to put an extra minus sign here. Meters per second. Awesome. And now with all of this, we can plug it in our calculator. So what we get out is a mass of the gas being 1.4 times 10 to the 2 kilograms. Cool.